right, derivatives. This is what we've been doing. And believe it or not, that's all the same stuff as you see right in front of you. When you hear the term derivative, that should almost be automatic for all 5 of these different things, and actually 6, because when you look at the slope of the curve at a point, or the instantaneous rate of change at a certain x value, or the slope of a tangent line at a point, or even if I write it in the form where you see the limit as h approaches 0 or the limit as x approaches a, graphically, that's what it looks like. And all of these mean f prime of a, or derivative. That is the most important piece. And last year, we even took the time to go through each one of these. We spent a lot of time practicing each of these methods, and then we discovered a shortcut. And today, my hope is that we can actually do that relatively easy. Now, in the first example you'll see here, it says let f of x equal x squared, and define f prime of a. So you'll notice it does not give us an actual number that we're used to seeing, where I want you to find the derivative at a particular letter. So I'm going to actually do this in the most formal way and show you what this actually amounts to. So here's what we got. We have the limit as x approaches a of f of x minus f of a over x minus a. Now, what's f of x? Well, that's x squared. What's f of a? That's a squared. And then we have x minus a in the bottom. I apologize, I forgot to write the limit here. X approaches a. Okay, so now what we want to do is we want to factor. So I have the limit as x approaches a of x plus a times x minus a. And the bottom, or the denominator, is x minus a. You'll notice the x minus a is divide out. And so I'm left with the limit as x approaches a of x plus a. As I said before, when you're evaluating the limit, basically what you're doing is you're going to plug in this a into this. So you have a plus a, which is 2a. And so that is f prime of a. That is the derivative. Now, we could also have done this in the way in which we use h approaches 0. That, of course, is a different format, but allows you to get the same exact answer. And that was in the previous video. I showed both of those cases. All that to simply say there is, in fact, a shortcut to this. And I want you to be looking for that shortcut so that when you get to the more elaborate type derivatives that we're looking for, you can do it quickly rather than having to do this lengthy equation every single time. So let's look at example number 2. Example number 2 says, given f of x equals x cubed, find f prime of a. So now what we're going to do is we're going to go to the limit. X approaches a again. This time it's f of x, which is x cubed, minus f of a, which is a cubed, over x minus a. In order to do this, what you would have to do, because you can't factor cubics at this point, you would have to do the division for this. Now, I'm going to do that off to the side here, and I'll even show you all my steps here. But I'm going to do x minus a, and I'm going to divide it into x cubed minus a cubed. You'll notice I have a little bit of space there because there are terms that aren't being included. Remember, like placeholders. We used to put zeros and stuff in there. But I'm not going to do that. Remember, x times x squared gives us x cubed, and so I'm going to put that down. And then x squared times that a gives me minus ax squared. Hopefully you remember that when you divide, you have to subtract. So we're going to change those signs. The x cubes divide out, and I'm left with ax squared. And if you want to, you can keep that a cubed coming down with it as we go. All right, so how do I get ax squared? Well, I would have to multiply by a and an x. And that, of course, would give me ax squared. So I get ax squared minus, and that would be a squared x. Again, don't forget, change the signs. The ax squared is canceled, and then I'm left with a squared x minus, we'll have that a cubed down there. So to get a squared x, I would have to multiply by a squared. And so that would give me a squared x minus a cubed. And again, switch your signs. And as you notice, everything cancels out and gives me 0 there, which is just exactly what I would expect. So what that means here is when I divide by x minus a, I am left with x squared plus ax plus a squared. Now to evaluate the limit, we're going to plug that a inside there, giving me a squared plus a times a plus a squared, which of course is 3a squared. Lovely. So now when it says f prime of 2, I don't have to now do this for f of 2 minus, or f of x minus f of 2, and then for b do f of x minus f of b, and f of x and all of that. All I need to do is plug in this value. So I'm going to plug in 2 into 3a squared. Because if f of a is 3a squared, then f prime of 2 is 3 times 2 squared, which gives me 12. And f prime of b then would be 3 times b squared, which would be 3b squared. And f prime of x would be 3 times x squared, which is 3x squared. Pretty simple there. Now when it says find the slope of the tangent line at 2, 8, remember this is just another way of saying f prime of 2. It's exactly the same question as part B there. In fact, I don't even need to solve anything. I just know it's already 12. Now, is there a relationship between x cubed and its derivative, 3x squared? Obviously, there is. There is some kind of relationship on how I can get from x cubed to its derivative, 3x squared. And can I use that same principle into something more extensive, as you see here? And if you recall, last year we learned that shortcut. And so I'm going to off to the side here. I'm going to actually erase my little division so that I can write right in here. But basically what we're looking for is, we notice that x cubed became 3x squared. In the question up above there in example 1, we learned that x squared became 2x. Is there something that we notice? How many of you remember the very idea that whatever this power is, let's say the power is n, what do we do to it then? Good. Hopefully we at least remembered that you're going to drop the n down in front. Whatever that power is, that power drops down in front. That's where those came from. And so this becomes n times x. And then what happens? See, this turned into 1. This was 2. Does this mean this one's 3? Of course not. It's n minus 1. It goes down 1 power. So now let's look at this. F of x. F prime of x then would be, this 5 is going to drop down in front, so this becomes 5x, and we go down a power, so it's 5x to the 4th, plus, now the 4 drops down in front, 12x, and that's going to go down a power to cubed. This 3 is going to drop down, so it makes minus 6x squared. How about this one? The power here is 1, so that becomes minus 5. And the x will go down a power to 0, and anything to the 0 power is 1, so we don't even need to write that. And what is the power of this one? There isn't an x there, but it's x to the 0, and so it zeroes out. It goes away. If you think about it, last year, remember the slope of a constant is 0. It actually all works out. All right, so let's now do this 4, number 4. Let's get right to it. F prime of x. So that would be what? Go ahead, pause the video if you want. And in just a second, I'm going to go ahead and put the answer down. But I'd like you to give this one a shot yourself and come up with the answer. Good. Did you get 3x squared plus 6x minus 2? Wonderful. I hope so. So then what does it mean when it says it wants the slope at 1? What that means is in place of x, in place of the x, we're going to put 1. So instead of 3x squared, it's 3 times 1 squared plus 6 times 1 minus 2. And solve that. Slope of the tangent line at 2, 12. Again, this is another way of saying f prime of 2. And so we're going to go 3 times 2 squared plus 6 times 2 minus 2. And so we have, again, 12 plus 12, which is 24, minus 2. Great. All right, how about this next one? Does this mean I have to do the 1 plus h method? Because no, absolutely not. What does this equal? What is this the same as? It's the derivative at 1. Excellent. What we're going to do is we're going to put that 1 now into the equation, except we already did that in B, so this is actually the same question as B. And just the same, in E, look at that. That's another way of saying I want the derivative at 2. I don't even have to solve that because that's the same question as C. Hopefully this was a great recap of derivatives for you. You should know how to do these, okay? If you are new to this calculus class and you did not take my pre-calc class, you definitely are going to want to do some extra work on your own looking up derivatives and how to do them. We've spent a lot of time. In fact, we spent about a month learning them in pre-calculus. So you're trying to learn in just 2 days what they learned in a month. So try your best. Certainly, feel free to come in for extra help as well. All right, good luck on your homework.